Hey, and welcome to another flip lesson for Algebra 2. This time it's on different ways we can write the equation of a line. So whereas our first lesson was on how we graph lines, this is going to focus more on different forms of lines. And so let's dive in and take a look at what we can do. So first of all, there are lots of different forms in which you can write the equation of a line. I'm only highlighting 4 of them here, 4 of the more popular forms, but know that there are lots of different ways we can write the equation of a line. Each different way or each different form has its benefits. There is a form called standard form. And you can see from this picture, standard form looks beautiful. It's very proper. It looks like a times x plus b times y equals c. A, B, and C are never fractions, so there's some manipulation going on to make sure those aren't fractions. And it's standardized. It's always written this way. It always looks nice. It's not super useful, but it's there to look good. There's another form called intercepts form. And intercepts form is where you can quickly identify both the x and the y intercept. And this is something we might talk about later on in class. But the two most popular forms for the equation of a line would be slope-intercept form and point-slope form. Now, slope-intercept form we've talked about before. I call this the workhorse of all linear forms. It always looks like y equals mx plus b. The m is very meaningful. The m represents the slope or the rise over the run. The b, also very, very important. The b is the y-intercept. And we've worked with this, and we had a video on this, and we have been working graphing lines. But when it comes to writing the equation of a line, I think there's a form that has been ignored, but it's probably the easiest. And I know in the last 2 years you've been working with slope-intercept form exclusively, but I want to open your eyes, and I want you to just try point-slope form today. So when we're graphing lines, we love slope-intercept form. When we're writing the equation of lines, this is a form I think you'll really like. Point-slope form, I have this picture of a spy because I think it's one of the best kept secrets that we have in math. It looks like this. It always has y minus something equals m times the quantity x minus something. Now, as you probably already guessed, m is the slope. But this x sub 1 and this y sub 1, those are just coordinates of a point. The x value and the y value of a point. Now, I'll get into how you use this, but let's just do a quick breakdown of which form should you use. And I guess if you're trying to decide which form you want to use, you have to ask yourself, what is it you want to do? Because if you want to graph a line, by all means, you want to use slope-intercept form. Again, this b, that's just the y-intercept, and then this m, that's your slope. The y-intercept is what gives you a starting point. The slope, this idea of the rise over the run, generates every other point you want. But if you're trying to write the equation of a line, if I give you information about that line and I want you to write an equation, point-slope form is the fastest, easiest way to do it. And I want to try to convince you to just try it today. Just try it tonight. Again, point-slope form, this m is the slope. You already know that. And then this y sub 1, this x sub 1, those are simply just a point through which that line passes. Any point. Doesn't have to be the y-intercept. Any point the line passes through. So let's go back and let's take a look at graphing lines. So example 1 in your notes. If I asked you to graph this line, well, graphing lines, that's where we want to use slope-intercept form. And this equation is already written in slope-intercept form. You can see right there that negative 3/4, that's the slope. This positive 2, that's the y-intercept. Now the slope is the rise over the run, and this negative out in front sometimes causes some issues with kids. You can either put that negative in the top, negative 3/4, or put it in the bottom, 3/4. It doesn't matter, but you have to choose one place only. And if you're graphing this line, you start at the y-intercept of 2 and you make a point. and then you use this idea of slope. Either the rise is down 3 and the run is to the right 4, or if you use this slope, the rise is up 3 and the run is left 4. And you eventually get enough points that you can draw a nice line passing through all 3 points. Boom. And that's how you graph a line. And we had a whole video on this, playing around, putting things in slope-intercept form to graph a line. Even some of the, let's just call it trickier problems like this, a little bit more of a fun example. If I asked you to graph this line. Now this line right here, 2x minus 3y equals 6, this is not ready to be graphed. It is not in slope-intercept form. It happens to be in standard form. Notice there are no fractions. The x's come first, followed by the y's, and the constants are over here by themselves. So what do we do to graph this? Well, the first thing we probably want to do is we want to get y equals mx plus b. We want to get the y alone, all by itself. And so if we're trying to get this y all by itself, maybe the first thing, this just is not cooperating. Maybe the first thing I'll do is I will subtract 2x from both sides. And that gives me on the left side here a negative 3y, and on the right a negative 2x plus 6. Again, I'm trying to get the y by itself. So how do I get rid of this negative 3? Well, I divide both sides by negative 3. And when I clean this up, I get y equals positive 2/3, negative divided by negative, minus 2, a positive 6 divided by negative 3. Once I have that, I can identify my y-intercept, which is the constant, the number all by itself, and the slope. And in this case, the slope is 2/3, or positive 2/3 is the same as negative 2 over negative 3. So once I have that, I can plot my y-intercept, which is right here. I can go up to right 3, again up to right 3, and use that slope to generate points. I could also go down to left 3, using the slope to generate points, down to left 3, and then I can just go ahead and draw in my straight line. And that's graphing. And we've done lots with graphing. But the next slide deals with how do you write the equation of a line. So let's learn how to switch to this different form and see how beautiful and easy it really can be. So we're going to write the equation of a line that passes through this given point, and that line has to have this slope. And this can be so beautiful and so quick and so easy. We're going to use point slope form. Point slope form generically, y minus the y value equals m, the slope, times the quantity x minus the x value. So I have the structure or the bones set up right here. I simply take my slope, which is 3/4, I put it there. I take my y value, which is 5, and I put it there. I take this x value, which is negative 2, and I put it here. And then all I have to do is just clean it up. So this is y minus 5 equals 3/4 times the quantity of x plus 2. Remember, a negative and a negative is a positive. That's it. You're done. You have just written the equation of a line that passes through this point with this slope. It's that simple. And I know in years past you always used slope-intercept form to do this, but I'm just here to tell you those days are gone. You have this beautiful form. And the amazing thing about it is you've actually known about point slope form ever since you've graphed lines. You just didn't know you knew it. And we'll talk about that in class. But let's do a couple more examples. For example, here's one. Write the equation of a line passing through these 2 points. Now remember, when we're talking about point slope form, we need to have a y value and an x value, and we have that. As a matter of fact, we happen to have 2 of each. but we also need the slope. So I think the first thing we need to do is we need to find the slope. So let's do that now. We know that the slope represents the rise over the run. And the rise is determined by the y values, and the run is determined by the x values. And so here's this equation for slope that you've been using for years. So let's just plug in the y values. Pick a y value, and it doesn't matter which one. I just picked this -1 right here first. And I took -1, this -1, minus this 5. And whatever you do in the top, you've got to follow that lead in the bottom. So since I started with this y value first, I have to start with this x value first. So this bottom would be 1 minus -3. And notice how that turned into 1 plus 3. And that becomes -6 over 4. And we should reduce that down to -3/2. Whoops. -3/2. So now that we have the slope and we have a point, actually we have 2 points, we can use our secret linear equation form. What is that secret form? It's this. Y minus something equals the slope times the quantity x minus something. So I'm going to take this slope right here, this -3/2, I'm going to put it here. I'm going to pick an x value, and it doesn't matter which x value. I'm going to choose -3 and put it here. Now notice the negative of the 3 changed the minus to a plus. And if I choose -3 as my x, I've got to choose this 5 as my y. It's that simple. We're done. We're done. It goes so quickly. Let's do one more example. One last example. We're going to write the equation of a line with an x-intercept of 3 that passes through -1, 2. Not a y-intercept, but an x-intercept of 3. Now, x-intercept of 3 means that it crosses the x-axis at 3, and that gives us this point 3, 0. So we have our 2 points. Our 2 points are 3, 0, the x-axis intercept, and -1, 2, the given point. Let's get the slope. Why don't you pause the video and see if you can find the slope on your own. Hey, welcome back. I hope you did that. I hope you paused the video. We know slope is the rise over the run, which is your change in y's over your change in x's. So in this case, I picked a y value. It doesn't matter which one. I guess I started with 2. And I did this y value of 2 minus 0. And you've got to be consistent in the denominator. So I did -1 minus 3. And that turns out to be -2/4, which reduces to -1/2. So once you get that whole thing, you go to your structure, which is point slope form. You pick any y value. In this case, I chose the y value of 0. I put in my slope of -1/2. And then since I chose the y value of 0, its partner value, x, would be 3. And that's it. You're done. So point slope form, believe it or not, you have actually known this form ever since you graphed lines. But it's way easier of a form to use when you're writing the equation of a line than slope-intercept form. And we'll talk more about where it comes from tomorrow. But tonight, I have a couple problems in your notes I need you to finish. So make sure your notes are complete and the problems at the end of the notes are done. Have a great night.